Today we're going to review some right triangle trigonometry. If we recall, a right triangle has one right angle and two acute angles. So if we look at one of the angles, we'll call it theta. Theta is a Greek letter used to represent an angle. The side opposite theta would be here. The side adjacent to theta would be here. Oops. And the hypotenuse is always the longest side of a triangle, which is opposite the right angle. There are 6 trigonometric ratios. We'll shorten that to trig ratios. We have the sine ratio, which is abbreviated SIN. So the sine of theta is the opposite side over the hypotenuse. The cosine of theta, which is abbreviated COS, cosine, is the adjacent side over the hypotenuse. And the tangent of theta, abbreviated TAN, is the opposite side over the adjacent side. So hopefully you remember that age-old Indian princess, Sokatoa. It's a good way to remember your sine, cosine, and tangent ratios. The sine ratio is the opposite over hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So let's look at this right triangle one more time. Let's keep in mind that the longest side, the hypotenuse, is always named the hypotenuse, and the two legs of the right triangle are always either the opposite or the adjacent. So the hypotenuse is never opposite over adjacent. All right, there are 3 more trig ratios. The inverse of the sine, 1 over the sine of theta, is called the cosecant. Cosecant is abbreviated CSC, cosecant of theta. It's the 1 over the sine, so it's going to be the hypotenuse over the opposite. We also have 1 over the cosine of theta, which is called the secant of theta, abbreviated SEC, secant, and that is the hypotenuse over the adjacent. And then 1 over the tangent of theta, abbreviated COT, that stands for cotangent, is the adjacent over the opposite. So those are the inverses of the sine, cosine, and tangent ratios. The inverse of the sine is called cosecant. The inverse of cosine is called secant. And the inverse of tan is called cotangent. And so notice that fractions are the same as the sine, cosine, and tangent ratios, except they are the inverse, the flipped fraction. All right, so let's look at a right triangle and talk about the 6 trig ratios. Here's a right triangle. One leg is 3, the other leg is 4, and we're going to be looking from this angle theta right here. So the first thing we need to do is find the hypotenuse of the triangle. So we're going to use the Pythagorean theorem. 3 squared plus 4 squared is equal to what squared? Okay, and so that would give us x squared is equal to 25. So the hypotenuse is 5. We could also remember that this is one of our Pythagorean triples, a 3, 4, 5 triangle. All right, so make sure that you can tell me the sine of theta, the cosine of theta, and the tangent of theta. Okay, so the sine of theta is the opposite side over the hypotenuse. The opposite of, if I'm looking from the angle theta, the opposite is 4, and the hypotenuse is 5. The cosine of theta if I'm looking from the angle theta, the adjacent side is 3, the hypotenuse is 5, and then the tangent ratio is the opposite over the hypotenuse, so the opposite side is 4 and the adjacent side is 3. Alright, so let's do cosecant now. The cosecant of theta is the inverse of the sine, so if the sine is 4/5, then the cosecant would be 5/4. The secant of theta is the inverse of the cosine, so if the cosine of theta is 3/5, then the secant is 5/3. And the cotangent of theta is the inverse of the tangent ratio, so if the tangent ratio is 4/3, then the cotangent would be 3/4. Okay, so we need to make sure that you can tell me the sine, the cosine, and the tangent, the cosecant, the secant, and the cotangent of any acute angle in a right triangle. Okay, so next we're going to look at our two special right triangles. Okay, two special right triangles are our 30-degree, 60-degree, 90 triangle. And if we remember the ratio of the sides, we have the short leg being 1, the hypotenuse being 2, and the long leg being the square root of 3. Some teachers put variables in and say it would be 1x, 2x, and x squared root of 3. And all that means is that no matter what the short leg is, the hypotenuse is going to be twice that, and the long leg will be that number times the square root of 3. And then we also have our 45, 45, 90 right triangle. And that is a special triangle because we know the ratio of the sides for that right triangle also. The two legs will always be the same length, and the hypotenuse will be that length times the square root of 2. So once again, some teachers put in variables 1x, 1x, x squared root of 2, and what that means is if whatever the two legs are, then the hypotenuse will be that length times the square root of 2. So for instance, if we know this, you can tell me what the sine of 30 degrees is. The sine of 30 degrees, if we look at our 30, 60, 90 triangle, the sine of 30 degrees is the opposite over the hypotenuse, so it's 1 over 2. The cosine of 30 degrees is adjacent over hypotenuse, so if I'm looking from the 30-degree angle, the cosine is the square root of 3 over 2. And the tangent of 30 degrees is the opposite over the adjacent. So it's 1 over the square root of 3, which simplifies to the square root of 3 over 3. So let's do 45 now. The sine of 45 degrees is the opposite over the hypotenuse. So if I'm looking from one of the 45-degree angles, the opposite is 1, the hypotenuse is the square root of 2, so that simplifies to the square root of 2 over 2. The cosine of 45 degrees is the adjacent side over the hypotenuse, and that's going to be 1 over the square root of 2 as well, so that's the square root of 2 over 2. And the tangent of 45 degrees is the opposite over the adjacent, so it's 1 over 1. So the tangent of 45 degrees is 1. So the purpose in me showing you this is to show you that with the special right triangles, the 30, 60, 90 triangle, and the 45, 45, 90 triangle, we don't really need a calculator because if we remember the ratio of the sides, and this is going to help us later on when we look at triangles or angle measures that are outside of a 45-degree, a right triangle. Okay, so the next thing we're going to look at is how do we find a missing side of a right triangle if we're given one of the angles I'm going to make a triangle here. So we've got, let's see, let's say we have a 35-degree angle here, and it's a right triangle. So let's say we're given one of the acute angles, and we're given the hypotenuse, and we want to find one of the legs. We can use trig ratios to find the missing side, because if I'm looking from the 35-degree angle, then I know the side that is right next to, excuse me, I don't know that one. I'm looking for that side, so I know I'm looking for the adjacent side, and I'm given the hypotenuse. This side over here, that would be the opposite side. So I don't want to use opposite here because I don't know that side, and I don't even want to find that side. So I'm looking for the adjacent side, and I know the hypotenuse. So which trig ratio, has to do with adjacent and hypotenuse? It's cosine. So we're going to write an equation that says the cosine of 35 degrees is equal to the adjacent side, which is x, over the hypotenuse, which is 10. And then we solve for x by multiplying both sides by 10. So x is equal to 10 times the cosine of 35 degrees. So we're going to go to our calculator. And the first thing you want to do is click the mode button and make sure that on the third line you're in the degree mode and not the radian mode. There are two ways to measure angles, in radians or degrees. Right now we're measuring them in degrees, so you want to make sure that you are in degree mode. Okay, then we'll go to the home screen and we're going to do 10 times the cosine of 35 degrees. And that will give us an approximate length of that side. So we're going to round to 3 places, 8.192. So we're going to say x is approximately 8.192.